This lesson is for Advanced Algebra, Lesson 8.5, Products with Radicals. It is important that students use a baby calculator only, so that's a calculator that doesn't have exponent button or any cosines or sines on it. So a four-function calculator only here. The first property kids are going to see involves two different bases that are being raised to a root power. Notice when you have 1 over n, that would be the same as you doing a root. And so we call the one that's in this format rational form because the exponent there is a fraction, also called a ratio. So this is a property that's in rational form because we're dealing with rational exponents. So notice what you're using here for this property. It's allowing you to put the two bases that are together and separate them out as long as you distribute the power to both pieces separately. Know that that also works when you're using a radical symbol. So this is the same property, just in a different format. So this is in radical form. So it's the same as raising to the 1 over n power, we're just using the radical symbol instead. So the property works the same way. If you have two bases that are under the radical, you can separate them into their own separate radicals. Keep in mind that radical form is the one we're going to focus on in Chapter 8, so your goal is always to simplify down to a single radical if at all possible. If you can go past the radical and get the number outside the radical completely, that's even better, but your goal is to do radical form versus rational form. So if you see here, the roots are the same. They both have a root of 3. If that's the case, then you can put them together according to this property. So the property works in both directions. So if I have two that are separate, as long as the roots are the same, I can put them together. So I'm going to say 4 times 16. And then go ahead and on the baby calc figure out what that is, and that is 64. So then we have to do a little bit of trial and error here to see if we know what that number is. Either you know it or you don't. If you don't, you have to do trial and error. So try 2 first. I know 2 cubed is not going to be 64, so I'm going to try 4 next because it's an even number. 4 cubed, I know that's 4 times 4 is 16, 16 times 4 is 64. Okay, so it's the number 4. So that one worked out really nicely. We ended up with just a nice whole number answer. So we didn't need to give our answer in radical form because we got a number that's outside the radical. Let's try one now with numbers and letters. Again, we can combine here because they're both the same type of root. So I'm going to say 2t to the 4 times 7t squared. Now the 2 and the 7 are being multiplied together. So I'm just going to write 14 there. And then t to the 4 times t to the second. Let's just write it real quickly over here so you can see it a little better. Keep in mind that we learned that property back in Chapter 7. When you have two bases, you should add the exponents. Very good. If it were t to the 4 squared, then we would have multiplied. So in this case, when there's two bases, we're going to add. So we're going to get t to the 6 there. Now that problem is finished. I'm going to be able to leave it like that because the number that's a power is smaller than the root. And let me just make sure that root looks right. It's supposed to be a little teeny tiny number right above that bracket. So when the power is smaller than the root, you can say that you're done on that question. If the power here was the same as or larger than the root, we would have to simplify further. And I'm going to show you how to do those in our next example. Before we get there, we got to write a few more notes. Remember when we did x to the m over n in earlier chapters? M is the power, or an exponent, and n is a root. And so we can separate that out into 1 over n and m separately. That's not our goal today though, but I want you to keep in mind that the top number is a power, the bottom number is a root. That's going to help you moving forward. Now I want you to copy this next statement. It might not make a whole lot of sense right now, but it will eventually later on in the video. If m is larger than the n, so the top number is bigger than the bottom number, try to simplify by thinking about the largest numbers for m that divide easily by n. We'll come back and revisit this statement again in just a minute, so if it doesn't make sense now, that's okay. So on this first question here, notice we've got a square root going on. And I know for some kids it's kind of nice to actually put the 2 in there so that you have it as a visual reference. But if you don't bother to put the 2 there, it's not wrong. This time everything's together under the radical, so our first step is to use the property in reverse. We're going to break them up. So I'm going to put the 4 and the y in separate brackets and multiply them together. So do we know the square root of 4? Well, yeah, that's a 2. So that one's finished. And then over here, remember this was a what root? Square root. If I wrote this in rational form, I'd end up with y to the 6 over 2, And 6 over 2 reduces to, yeah, y to the third. So that's our final answer, 2y to the third. And I don't need a radical here because everything came out of the radical. The 6 and the 2 simplified, and the 2 simplified, so we're done there. 2y cubed is our final answer. Similarly, on number 4 here, again, we're going to rip apart the pieces. So I've got 4th root of 81. I'm going to do the x separately, and the y separately as well. So now I've got 3 things I've got to deal with. 4th root of 81, I want to think about a number times itself 4 times that equals 81. Students are used to doing that number or that question like this in the past. So raising to the 1/4 power. So you might remember that that number is a 3. If you didn't, you'd have to do trial and error. So that turns into a 3. Over here, notice that the power is smaller than the root, so that one's actually good. No simplifying to do there. How about over here with the y? We've got an 8 for the power and a 4 for the root. 8 divided by 4, if we set it up like this, that's going to be a 2, so we get y squared. Now let's assemble all the pieces. Anything that's under the radical is going to go on the right. Anything that's not under the radical goes on the left. Make sure that numbers go in front of letters and that the letters are alphabetical. So our final answer is 3y squared. Those two pieces get put together. I'm just going to cross them out so I know that I've used them up. And then I've only got one thing left under the radical. Let me write it in the right color here. So I've got 4th root of x cubed still underneath that radical sign. And then that's my final answer. Now that final answer isn't very pretty looking, is it? It's kind of ugly. But that's okay. What we did is we simplified this by pulling out as much of these pieces as we could so that it's in front or outside of the radical. Some of the stuff is going to maybe be left over. Like in this case, there's some x's that are left over, but the 81 and the y's got pulled out, so that's good. That means we've simplified it successfully. Let's try a few more here. Again, we're going to rip apart the pieces so that they each get their own radical. The reason we do that is just easier to deal with one thing at a time. So square root of 12, if we typed that in on the calculator, we'd get a decimal. So what I want to do is try to think about some numbers that go into 12 that I can simplify. So if you think about square root numbers, you probably have the square root list of numbers memorized. 2 squared is 4, 3 squared is 9, 4 squared is 16, and that list can continue. So I want to see if any of those numbers go into 12 evenly. And I know already that 4 does. So I'm going to say square root of 4, square root of 3. So whenever you're working with a number that doesn't have a root that you can figure out exactly, you're going to look for factors of that number where one of them you do. So 4, I know the square root of that is going to turn into a 2. The square root of 3 is just going to be stuck under the radical. He has to stay. Then we do the same thing with the y's. Now remember, this is a square root. So if I did 7 over 2, I'd end up with a decimal there, and that's no good either. So what I want to do, let's go back to my little note here. When m is larger than n, try to simplify by thinking about the largest number for m that divides easily by n. So right now 7 and 2 don't divide evenly. So what I'm going to do is separate the y's into 2 separate ones. And I need to come up with some powers here that add up to 7. So let's list out my options there. 6 and 1, 5 and 2, 4 and 3, or we could do 3 and 4, 2 and 5, 1 and 6. So those pairs of numbers are the only ones that will add up to 7. And I'm going to do an add here because if I do y to a power times y to a power, what happens to the powers? Yeah, we got to add those together. So that's why I want numbers that add up to 7. But I want to pick the pair that I can divide the 2 by. So this one will work, but I want to pick the largest. So 4 works, but 6 is the biggest one. So let's pick 6 and 1 here as the numbers that add up to 7, but notice what's going to happen to this one. Since it's a radical with 2 there, the 6 and the 2 can divide, so we end up with y cubed. This one, the power is now smaller than the root, so that one we can't do anything. He's stuck under the radical. So now let's grab all of our stuff and arrange our answer in the right format. So grab all the things that are not under the radical anymore. So that was the 2 and the y cubed. So those are done. And then the 3 and the y back here, those are still under the radical. So I'm going to do a radical sign 3y. That's my final answer. So your answer was back here, we just need to put it together. So we separated it out into different pieces, and then when you're all done you got to reassemble it. So let's keep trying a few more of these. Now we got a cube root of 120, so let's separate the 120 from the x. And again, let's see what we can do here. Let's think of some cube roots that we know. First cube root is 2 cubed, that's 8. 3 cubed, 27. 4 cubed is 64. I know that because I did that one earlier today. So let's see if any of these divide evenly into 120. So let's start with 8. 120 divided by 8. What happens there when you type that in? 120 divided by 8 is 15. So we get the 8 and we get the 15. 8 times 15 would turn back into the 120. Cube root of 8, though, we know is a 2. So that worked out well. The cube root of 15, he's going to stay. He's the leftover. Then we're going to do the same thing to the letters. So I'm going to break this up into an x and an x, and now I got to be strategic about the values that I pick here. These exponents have to add up to 4, but they need to divide by 3 as well. So my options are 1 and 3, 2 and 2. Well, 2 doesn't divide by 3, so it's got to be the 1 and the 3. Really only have one option there. So I'm going to use 3 and 1. 3 divided by 3 here is going to make that x to the 1 with no radical. This x to the 1, since the power is smaller than the root, he has to stay. Now assemble all the pieces. Not under the radical are the 2 and the x. Still under the cube root radical sign is the 15 and this x. And there's our final answer there. Got one more for you to try here. Again, we're just getting harder and harder as we go. And then I'm going to have you try one more problem from the homework. 5th root this time, so this one's super tough. But let's see if you can handle it. Again, separate out all the pieces. And let's go for it. 5th root. Alright, so I don't know any of the 5th roots by heart, so I'm just going to figure those out right now. 2 to the 5th. So 2 times 2 times 2 times 2, that's going to be, let me think that through for a second. That's going to be 32. Oh, isn't that going to work right away for us? 32 times 3 is 96. I can do that one in my head. So I got on the first try. It's kind of nice. Got 32 and 3. 32 times 3 is 96, and I know the 5th root of 32 is 2. So this one turns into a 2, that one's finished. 5th root of 3, he's going to stay under the radical. I can't do anything further with that. Good, so that one wasn't as bad as I thought. 5th root of x to the 1. Notice that the power here is smaller than the root there, so nothing we can do with the x. X, I got nothing for you, man. Can't do any simplifying there, he's just going to stay where he is. Now with the y's, 12 and 5 don't divide evenly, so that one I'm going to have to monkey around with a little bit. So I need to pick some numbers that add up to 12, because I'm doing y to the something times another y to the something. When I have two bases, the powers get added. We did that back in chapter 7. So they got to add up to 12, but I want the biggest number possible that can divide by 5. So I got 11 and 1, 10 and 2. Oh, right away I think I'm good. The 11's not going to work, but 10 divides by 5. Anything smaller than that is going to be smaller, so I don't want any smaller results. So 10 and 2 is what I'm going to pick. Now you could be thinking, what about 5 and 7? 5 and 7 works, but then the 7 still needs to get divided also. So it's better to pick the largest number. That's why we wrote that back up here. Pick the largest number for m that divides easily by n. There are other numbers, you always want to pick the biggest. So we got the 10 and the 2 there. The 10 divides by the 5, giving me a y squared. Not under the radical anymore, because those are nice even numbers. This y squared has to stay under the radical because he's smaller than the root. Now let's assemble all the pieces. Be careful, there's 1, 2, 3, 4, 5 things I got to deal with. Not under the radical anymore is the 2. That's radical, this isn't, so that's y squared. Then be careful here, write your little 5th root. And then under the radical, do the numbers first, so that's the 3. and then do the letters in alphabetical order. I've got an x and I've got a y squared. Be careful here when you write that. You want to make sure there's some space here so that this doesn't look like a 25. This needs to be the exponent on the y only. It cannot run into the fifth root in the radical symbol. Also make sure your fraction or your radical bar is long enough, because this y squared needs to be under the bar. If you're in a hurry and you mistakenly do a 2 like that, that could potentially be confusing or incorrect. So make sure you're being real careful about where your bar goes. So it's 3xy, and then the square goes on just the y. And that needs to be under the bar. Alright, I think it's time for you to try one on your own. Actually going to have you try 2 on your own. In class we had done this one, or we potentially might have done this one in class already, but I will display the answer for you here in the video. And then I want you to try number 18 in the homework as well. So give those 2 a try, pause the video, answers will be displayed shortly. So here you go for the 1250 number. When you're doing cube roots of that, a big hint here for you is anytime a number ends in 0, try taking off the 10 and see if that number can divide evenly, and that's usually the case. Not always, but sometimes that's a good method to use. So I took off the 10, I was left with 125, and I knew that the cube root of 125 was 5 already. So that one made that one pretty easy. And then the leftover 10 is still under the radical. Over here, again, I separated out the numbers, the x's and the y's. The number, used the same technique here. I pulled off the 0 with a 10, leaving me a 64. I know the cube root of that because we've used it 3 times in the video already. I know that that's a 4. The cube root of 10 has to stay. And let's look at the x's here. The power 12 and the root 3 divide evenly into a 4, so that one's good to go. No monkey business there. That one works out real nicely. For the y's, we've got 11 for the power and 3 for the root. 11 doesn't divide by 3, so I do need to figure that out. Biggest number that divides by 3 that's below 11 is the number 9. That leaves me the 2 left over to get back to 11. So the 9 and the 2 add up to 11, but the 9 and the 3 divide evenly. So that gets me y to the 3 there. I've got these 2 that are still left over. Then I just took all 5 pieces and assembled it. The 4 was not under the radical, the x to the 4 was not, and the y to the 3rd was not. Those go in alphabetical order. Then under the radical still we've got the 10 and the y squared. And again, make sure your 2 is underneath that bar.